Hello, everyone. I'm Professor Nguyen, and welcome back to Organic Chemistry. All right, we're moving on to the next few different classes of organic compound. These are oxygen-containing compounds, which include alcohol, ether, aldehyde, and ketones. And there should be one more in the next chapters. That's carboxylic acid, ester, so on and so forth. Okay, now here's all the basic, the functional group. If you guys still remember from chapter 7, alcohol is organic compound that has OH, the functional group OH. Ether has oxygen but no hydrogens. It's carbon on both sides, and you got an example there. Aldehyde is a acetyl bond O with the hydrogens, and ketone is just acetyl bond O. Okay, so let's get right on to it. Alcohol first. Okay, alcohol is a compound with OH. Pay attention to the carbon bearing the OH. Okay, there are three different types, and this is called a primary alcohol. It's a carbon that has an R, which is a branch, with something with a carbon. Okay, and that's one R, one bonded to another carbon. Now, if it's a secondary, if it has two, you can think about them as branches, carbon branches, okay? Branches with carbon, and that's secondary. And three branches, it could be 3-methyl, and that's tertiary. All right, now let's name. Find the longest carbon chains with OH and start numbering on the side closer to OH. All right. Now, if it's a cyclo, obviously that's number 1. And then you go this way, 2, 3, 4. It doesn't matter which way you go, end up number 4 anyway, so that's good. So we got 4. We have another 4 because we got 2 of them. That's what we call 4,4-dimethyl. And it's a cyclohexanol because it's an enclosed structure. Notice we don't have to mention number 1, okay, because it's a cyclo. All right. However, if it's not a cyclo, it's a straight one, we need this number 1 right there for the non-cyclic one. Okay, so that way we know where the OH is. Okay, so that's 1 that has the OH. And then 2 has 2-methyl, 1 on top, 1 on the bottom. 3, 4, 5, 6, so we have a total of 6. Okay, so that's 2,2-dimethyl, 1 hexanol. Okay, hexanol because it has a total of 6 carbon according to the numbering. All right. And you can go back to that table if you remember on chapter 7, the table that has 10, actually more than that, alkanes. Okay, and it's based on the number of carbons. That's a very good table of fundamental alkanes. Okay. Okay, here's more. Now, this one, the best is to go with the carbon here because this carbon has an OH, so that's why it's so important. And that's got to be number 1. Okay, 2, 3, 4. Actually, it's only 3. And then you have, I remember I circled this. It's a branch. We treat that as a branch. This is the easier way. So that's a 1-cyclohexol. Notice it's not a cyclohexane. Cyclohexane if it's by itself, but if it's a branch, it has to be cyclohexol. And it's also 1 alcohol, which is a propanol, because it's got 3 carbons. Okay, and here's another good one. Number 1, obviously. 2, 3, 4, 5, 6. So that's a 1. Not only is an alcohol, but it also has a branch as well. It's when they get 2 carbon branch, it's called ethyl. In another video, I talk about all kinds of branches, so you can check that out. Okay. Now, and that's a cyclohexanol. Okay, cool. Some common alcohol like methanol, ethanol. Okay, it's one carbon, 2 carbon. We call ethanol. Okay, so here's some practice for us to do. Draw the structure for the following alcohol: isopropanol, isopropyl alcohol or 2-propanol. You could do the line formula way, or you can do the condensed formulas. Okay. Number 2, we got an alcohol. Number 2, we got an alcohol. 4-ethyl 4-heptanol. Hepta means 7. 1, 2, 3, 4, 5, 6, 7. Start out with 7, and it's 4. We have an alcohol. We also have an ethyl. Notice I've got 2 dots. That means 2 carbons. That's ethyl. And you can do it the condensed way as well. This is actually a better way, okay? But we need to know both ways. Okay, cyclopentanol, that's just a cyclopentane with an alcohol. Cyclohexanol, that's 1. Automatically number 1, but that's a class. Alcohol, that's very important functional group. 2, 3. So we got 3 ethyl, 2 methyl, because remember alphabetical order, ethyl's got to go first. And 1 hexanol. Oops, I think I made a mistake here, everyone. This should be cyclohexanol, no 1. That's bad, all right? Because it's a cyclic, you don't have to put numbers on. And I'm missing a cyclo, okay? So please fix that. So it should be 3 ethyl, 2 methyl, cyclohexanol. Okay, pretty good, everyone. If it's a hexanol cell, it would be a straight, straight line. Okay, we can do that too, of course. Aromatic alcohol, known as phenol. Benzene alcohol, known as phenol. You can draw this way, or this way. Okay. All of these are from the phenol family. However, of course, they have different specific name. 1, 2, 3, so that's a 3-methyl phenol. 1, 2, 3, 3-ethyl phenol. We got 2 branches, that's 2, 4. Remember, the OH right there, that carbon is always number 1, okay? That's a fixed one, but that's so important. That's the most important functional group in this molecules. This molecule has 2 functional groups, by the way, alcohol and aromatic, okay? 1, 2, 3, 4, so 2,4-dimethylphenol. Again, 2 functional groups, aromatic and alcohol, okay? Also known as phenol. 1, 2, 3, 4, 4-chlorophenol, isopropyl. Ooh, you guys see the 3 dots connect right in the middle? That's called isopropyl. 3,4-dibromophenol. Okay, pay attention to the numbering. Very important. You number correctly. Okay. Okay, so that's alcohol. Now next, ether. Treat ether like 2 branches on the oxygens, and arrange the name in the alphabetical order. That's the easiest way to name ether. So you got oxygen right here, that's ether. On the left side you have a methyl, CH3 is a methyl. On the right side you have CH and 2-methyl, that's called isopropyl. Isopropyl will go first, isopropyl methyl ether. Okay, now this one, on the right side you have ethyl, on the left side you have phenol. So ethyl phenol ether. Okay. We got some more for you guys to practice. Okay, you can print out a blank one and then practice and then check the answer. Okay. The for this chapter, I don't believe I have homework for you guys, but if you do this, that will count as homework. All right. But you gotta try yourself first. Okay. Now we got a propyl and we got a cyclopentyl. So cyclopentyl's gotta go first. Cyclopentyl propyl ether. Make sure they're all separate words. Don't stick them together. Okay. Here we have ethyl and methyl. So ethyl, methyl, ether. The words ether always go last, so that's not part of the alphabetical order. Okay. Dimethyl ether, but that's a class name. That's functional group name. Very important, so it has to go last. And we also have diethyl ether. we got a methyl branch on the right, and then the benzene by itself, but if it's a branch, if it's connected to something, it's called phenol, um, and that's methylphenol ether. And number 6 asks us to draw the structure of isopropyl propyl ether. Propyl is 3 carbon in series. Iso is connect in the middle. Okay. All right, we good, everyone, so far? Now, aldehyde ketone, name ends with al for aldehyde, on for ketone. Okay, so we got ethanol, 2 carbon, ethane, aldehyde, we call ethanol, or acetaldehyde. Propanol means 3 carbon, propane, aldehyde, so we call it propanol. Um, this one, 1, 2, 3, 4, 5, so that's a 2 ethyl, CH2, CH3, the whole thing is called ethyl, that's methyl. So 2 ethyl, 4 methyl, pentanol, pen means 5, okay. That's benzene aldehyde, so we call it benzaldehyde, make it shorter, nice. Right. Ketone end with on, so we got 1, 2, 3, 4, 5, 6. So we have to tell where is the ketone, number 3. That's what we call 3-hexanol. Hex because it's 6. Now, you're not responsible for this because it's a multifunctional group. Alkene and ketone, okay? But that's how you name it. 4-hexene, 2-on. This is a dione, diketone. We're not responsible for, but if you wonder how, this is how you name it. It's the dione. 2,4, ketone number 2, ketone number 4. So we call it 2,4-hexane dione. Diketone is dione. There's popular one that we need to know. That's acetone, which is dimethylketone. Methyl on the left, methyl on the right. Dimethylketone, known as acetone. Methyl on the right, phenol on the left. We call this acetophenone or methylphenolketone. There's both benzene on the left and right of the ketone. We call it benzophenone. Benzophenone, very nice, right? All right, we got some practice here for you. And check it out and try for yourself first. Treat it like homework and then check the answer, okay? In terms of reaction, we do have a few reactions that I would like you to know for the test, be able to predict what the products are. When you, first is the oxidations, okay? Oxidizer is our example of oxidizer are PCC, that's pyridinium chlorochromate or sodium dichromate. Now, when you oxidize a primary alcohol, you turn that into an aldehyde. If you keep oxidized further, that's going to turn to carboxylic acid. So know that, okay? General idea. Secondary will be oxidized to become a ketone. And if you have a tertiary alcohol with 3 branches, it's not going to happen. No reactions. We cannot make a double bond because that will make a 5 bond for carbons. That's not allowed, okay? Too many. Okay, so that's oxidation. So the symbol for oxidation is the oxygen in the bracket. Oxidation is about oxygens. Oxygens in bond. So every time you see oxidation, make the double bond with oxygen. Okay? That's it, you're done. Don't worry about the rest. Oxidation, make double bond with oxygens, and you're done. Oxidation, but hey, that's a tertiary, can't make a double bond. The carbon will have 5 bonds. That's not allowed. Okay. Oxidations, make a double bond. It looks weird without a hydrogen. That's why we stick the hydrogen in. It's always there. Oxidize another one, become carboxylic acid. Dehydrations mean losing water or losing OH. Okay, and of course also losing another hydrogen, become water. Now the cyclohexanol, the OH will be gone. Dehydration means losing it. It become a double bond, okay, with the carbon. And every time you see H2SO4 in heat, meaning dehydration. And I put the arrow right here, mean losing water. Okay. And so for this one, I didn't have it the answer there, but you would put a double bond right there. Get rid of the OH and put a double bond between number 3 carbon and number 4 carbon. Draw another bond right there. That's your products. And this one, between carbon number 1 and number 2, you make a double bond right there. Draw another line right there. And eliminate OH. OH will be gone as water. Okay. Uh, the last couple reactions will be the oxidations with Tollern reagents. And that's, for example, benzaldehyde will turn into a carboxylate ion. That's benzoate plus silver. Okay. This is called Tollern reagent. It's a silver ammonia complex. And when you do this in the test tube, it's beautiful. Uh, you get a silver lining, shiny silver lining in the test tubes. Okay. And if you do with Benedict reagent, which is the copper solutions, and you might have to warm it up a little bit, but it turns beautiful red color. Sometimes it's like red green colors. Okay, and that's the indication of the aldehyde. Okay, that react with the Benedict reagents. Pretty cool. All right, and I believe that's it for aldehyde, for alcohol, aldehyde, ketone, alcohol, ether, aldehyde, and ketones. Okay. All right. Thank you guys for watching. And in the next chapters, we're going to be talking about carboxylic acid, ester, amine, and amine. And that's it. That will cover um, all types of organic compound that we want to talk about. All right. Thank you guys for watching and have a wonderful day. Okay. See you guys soon.